Good morning. This is your Stat Sensei, Mr. Spensei, and this is scenario 2 on regression crawling season. All right. So, at what age do babies learn to crawl? Does it take longer to learn in the winter when babies are bundled and movement is restricted? There might be an association. In other words, there might be a relationship between the baby's crawling age and the average temperature during the month when they first tried to crawl. Data were collected from parents who reported the birth month and the age at which their child was first able to creep or crawl a distance of 4 feet within 1 minute. Information was obtained on 414 infants, 208 boys, and 206 girls. The average crawling space in weeks and the average temperature in degrees Fahrenheit is for the month that is 6 months after the birth month. So they took the averages. So we have that's why we have each month in January, the average the average age in weeks was 29. In February, it was 30, et cetera, et cetera. So the very first thing I need to do is I need to go to stat edit and enter this data. But before I do that, I'm going to clear my calculator and I'm going to go to mode and make sure Stat Diagnostics is turned on and Stat Wizards is turned on. If they're not, highlight them and press enter. Once that's done, you can quit out of that and go to Stat Edit and enter the data into L1 and L2. I've already done that, so I have average temperature in L1 and I have crawling age in weeks in L2. Once I've done that, I'm going to go ahead and run my test. So Stat Test, Linear Regression T-Test, press enter, and I have L1 and L2. I'm looking for a not equal. This is always a little bit weird, but we're going to press the green button followed by the trace, so alpha trace, and just press enter. And we're going to calculate, and we get a ton of information. So I want to back up real quickly because our regression equation is written as y hat equals a plus bx. And a is our y-intercept. And B is our slope. So let's make sure we pay attention to that. A, y-intercept. B, that's our slope. All right. So we've run that. So now we can go ahead and fill in our information because I can look and go, oh, A is 35.67. So there's my y-intercept. B is negative 0.077. So there's my slope. So I've already recorded that. There's my y-intercept at A, 35.67. There's my slope, negative 0.077. The next thing it asks for is the coefficient of determination. Please remember, coefficient of determination is our r squared. And when it says 0.489, all right? So this is always r squared. And by the way, I guess I should highlight this. This is my slope. This is my y-intercept. And this is my r squared. Then the next thing it asks for is the correlation coefficient. Well, it gives me that, but make sure you catch that negative. It's negative 0.6997. All right, and it's very related to the r squared. We're going to come back and look at that. But while we're here, we're also going to get our s. And our s is 1.3191. And I just pulled that straight off the calculator, and that's our standard deviation of our residuals. So S, our standard deviation of residuals, is 1.3191. Now, I said I wanted to come back and talk to you about the correlation coefficient. If I take the square root of 0.4895, let's quit that. So I'm going to take the square root, blue square root, 0.4895, I get 0.6997. Hey, that's what we already have. So this is just the square root of r squared. All right, this is just the square root of r squared, but there's one other thing you have to be careful of, and that is you have to pay attention to the slope. The slope was negative, so this is also negative. So always look for the sign of the slope. If the slope is positive, this will be positive. If the slope is negative, then the correlation coefficient will be negative as well. The next thing it does, it says regression equation. Well, we've already said that regression equation was simply y hat equals a plus bx. So we're just following along. Y hat equals a plus bx. Just happens to be that we have a minus sign because our b happens to be negative. Next thing we need to do is predict the age for March. Well, March was 72, was our temperature. So we're going to go, okay, we're going to write our regression equation or to plug it in, 35.6780 minus 0.777 parenthesis. March was 72. So we plug that in parenthesis. Oh, excuse me. I made a typo there. Let me clear all this stuff out. All right. 35.6780 minus 0.0777 parenthesis. March is 72. And we get, oh, we expect them to be at 30.08 weeks. All right. All we did was plug in 72. We just plugged in this value. You know what? I should have done that in pink because that's a x value or slope, because this is what we have right here. The next thing is prediction for August. Well, August was 30, so we're going to take our regression equation, 35.6780 minus 0.0777, and plug in 30. And we end up getting 33.347 weeks. The next thing it's going to ask you to do is to calculate all the residuals. So stat edit, we want to go to stat edit. We're going to go to top of L3 and we're going to press blue, then list. Residuals should pop up. All right. By the way, if residuals doesn't pop up, you need to go back to stat test, linear regression t-test. And when you get to here, press the green button followed by trace. All right. Now we're going to go to stat edit. I'm going to clear that out. And you go blue list, scroll to 7, and it should populate. So there's our residuals, and I'm not going to sit there and leave it here very long just because the calculator did all that work for us. The next thing we need to do is sketch a scatter plot. To sketch the scatter plot, we're going to go quit out of that, clear the screen, and we're going to press the blue button and the button directly above it, the Y equals, and press enter. On button needs to be highlighted. We actually want the first graph. If it's not highlighted, press enter, highlight it and press enter. Our X list is L1, so blue 1. Our Y list is L2, so blue 2. And then we're going to press zoom followed by the number 9. And I always like to draw the line when I'm drawing my sketching the scatter plot, just because it helps me plot my points. But when I draw it, it's going to look something like that. Okay, and that looks pretty close to what I have. And I just, like I said, it helps me to actually draw the line, to draw the scatter plots better if I graph the line as well. The next thing it's going to ask me to do is a residual plot. And I'm going to go second stat plot. You know what? I should back up out of that. Let's go to look at stat edit real quickly. Our residuals are L3, so we're going to want L1 and L3. So blue stat plot, or blue button and the button above it, press enter. It should be on. We can leave everything the same, but I need to change my Y list to L3. And by the way, all residual plots are centered on 0. Once I've gotten to the bottom, I press zoom followed by the number 9, and there it is. All right. So this is always centered at 0. And when I look at that, that's a random mess, which is a good thing. All right, so we have a random mess. We're centered at 0. I don't bother drawing the line because I have a 0 line to compare my dots to, and that looks random. So our question is, based on the residual plot, is a line an appropriate prediction model? And the answer is yes. A line is appropriate because there is no pattern to the residual plot. And I'm going to add, and it is random. We want it to be random. I have no idea if the next point is going to be above the line or below the line. All right, because it's completely random. That's what we're looking for. I sure hope this helps. Look forward to seeing you on the next one. Thank you.